Okay, boys and girls, welcome back for some guided and independent practice with the distance formula. You should have a piece of paper, a calculator, and a pencil in front of you. You've opened the assignment already. You've looked at the PDF document. You know what it is we're doing. Okay, I'm going to work on my tablet while you guys work on the lined paper. Again, just like yesterday, you're going to put your name and date at the top. Oh, let's see here. 10, no, 12.4 is the distance formula. This is classwork. And today is 4/2/2020, April 2nd, 2020. Okay, and we're going to do numbers 1 through 8 and numbers 41 through 49. Okay, I'm going to do a few with you and you're going to do the rest on your own. I'm going to work on my tablet. You're working on your paper. Let's see what we got here. All right, so I'm trying to find the distance between a pair of points. Round your answer to the nearest tenth if necessary. I'm going to start just by rewriting this distance formula up here one more time. Probably not one more time, probably a lot more times. Distance equals the difference between x sub 2 and x sub 1 squared plus the difference between y sub 2 and y sub 1 squared. Okay, so we're going to label our points, right? We're going to label them x1 and y1 or x2 and y2, and we're going to use that formula. So we're going to put x sub 2, 7, minus x sub 1, 18. We're going to square that, and we're going to add y sub 2, 13, minus y sub 1 minus negative 4. And we're going to square that value, and we're going to take the square root of the whole thing, and that's going to equal the distance between those points. Okay, so we have 7 minus 18 is negative 11 squared, and if we square a negative value, we're going to get a positive value. Negative times negative is positive. And 13 minus negative 4 is actually 13 plus 4, so that's 17 squared, and that's equal to D. And you know what? I'm gonna grab my calculator here and check this out. Let's see here. What was I just looking at? Negative 11 squared and 17 squared. Okay, let's try. Negative 11 to the second power plus 17 to the second power equals, so we're looking for the square root of 410. And that's going to be 20.2. 20.2. So D is approximately 20.2 to the nearest tenth. Okay, and make sure you're checking your answers on the answer key in the back. Okay, the next one, we're going to do the same thing. I'm going to label these points x1 and y1 and x2 and y2, right? Those are my 2 points on the coordinate plane. Okay, and now let's see here. I'm just going to plug those values into that equation. So I'm going to do the square root. X sub 2 is negative 4. And x sub 1 is negative 7. So I have to subtract negative 7. And I'm going to square that. And then I'm going to add the difference between y sub 2 and y sub 1, negative 15. Minus negative 11, negative 15 minus negative 11, which is actually a plus, right? So I have negative 4 plus 7. Negative 4 plus 7 is 3 squared. And I have negative 15 plus 11, so that's plus negative 4 squared. And so what I have here is the square root of 9 plus 16, which is the square root of 25. And every one of these is equal to the distance between those 2 points with x and y values that are given. Okay, so the distance between those points should be equal to 5. Okay, now let me see something here. See if we can get this. Sorry I didn't do this before. 20.2 and 5. So we're good. We're doing it the right way. We've checked our answers. So now we're going to go back here. I'm going to do a couple more of these guys with you. Let's see. We're going to label our points. x1 and y1 and x2 and y2. This is not new. We've worked with points on the coordinate plane like this before, and we're going to put those values into our formula. So 20 minus negative 16 is actually 20 plus 16 plus, let's see, 20 minus 3, 20 minus 3 is 17. So now I have 36 squared plus 17 squared, and I want to find the square root of that value. So I'm going to use my calculator. I'm going to do 36 up 2 plus 17 up 2, and that gives me 1,585, and then I'm going to find the square root of 1,585, and that equals 39.8. 1,585 is equal to D, is equal to D, is equal to D. And so D is equal to 39.8. 1 tells that 8 to stay the same. Okay, we're going to go over to number 4. I'm just going to keep rolling right along. You guys can pause the video as you need to, right? Finding the distance between these 2 points. So if I plug those into the equation, right, write it as many times as you have to. Find the difference between the x coordinates and square it. Find the difference between the y values and square that, and then take the square root of the whole thing. So negative 14 minus negative 19 is plus 19. So I'm just going to change that right away. And then plus, let's see, y sub 2 is negative 9, right? Negative 9 minus y sub 1 is negative 10. So I'm actually adding 10 there. So what I have here, distance is equal to the square root of, that's 5 squared, negative 14 and positive 19 plus negative 9 and positive 10 is 1 squared. So what I have here is the square root of 26. D equals the square root of 26, and the square root of 26 is approximately 5.099, so 5.1. So D is approximately 5.1, and that's the answer I got for that one. And I'm going to go back. Let's see here. 5.1, check, 1, 2, 3, 5.1 and 39.8. All right, so I'm going to go back here, and what we're going to do is, actually, we're going to go to number 41. You guys are going to keep working. You're going to solve 4 more problems on your own, and then I'm going to go to number 41 with you, and we're going to solve a few of these together. and then you're going to work on your own for a few more minutes, okay? Here are the directions. We're always reading the directions until we understand them. The directions here tell us find the distance between each pair of points around your answer to the nearest tenth if necessary, okay? So I can use a couple different strategies here. I can do this a couple different ways. I can make a slope triangle, right? I can go right here and right here, and that's going to give me a right triangle. My right triangle's right there, okay, and I have 1 unit here, and I have 1, 2, 3, 4, 5, 6, 7 units there, okay? So I'm going to say that A equals 7, and B equals 1, and C, my hypotenuse, is that opposite side. So you'll notice I'm not using the distance formula here. I'm going to use the Pythagorean theorem. So 7 squared plus 1 squared equals C squared. So 49 plus 1 equals C squared. So the square root of 50 is equal to C, right? Because if I take the square root of both sides, the square root of 50 is approximately 7.07 or 7.1. Okay, so that's using the Pythagorean theorem. That's connecting these dots. You also could have take that all away from there. You can label these points. This point here is 2, 1. And this point over here on the far left is -5, 2. -5, 2. And if you label these x1 and y1 and x2 and y2, you can do the same basic thing. Oh no, now I'm frozen. You can do the same thing well, my pencil doesn't want to work anymore. Let's see here. We'll improvise. So my points are -5 and 2, 41. -5, 2. And for 41, you can use the distance formula or the Pythagorean theorem, whatever works. Again, my other points are 2 and 1. Okay, so x1, y1, x2, y2. Let's see here. Let's see if I got this. So I'm going to put those values into that little radical symbol there. And I'm going to do x sub 2, 2 minus x sub 1, which is a negative, so I'm actually adding. And then y sub 2 is 1, and y sub 1 is 2. Okay, so what I have is 7 squared plus -1 squared. And I'm going to find the square root, and that's 49 plus 1. And so we've got the same thing here again. Okay, that's all we're doing. And that's number 41. D is equal to the square root of 50, which is approximately 7.1. Okay, number 42. I'm going to go on. Let me see here. Number 42. Number 42, I can label my points. That is 5, 5, x1 and y1. I'm just kind of bouncing back and forth between the paper and the tablet. Technology is not cooperating that well for me tonight. And the y value is 0 there. Okay, so that's x2 and y2. And I can use the distance formula, or I can just draw out a little slope triangle here. I can find the length of the legs. 1, 2, 3, 4, 5, 6, 7, 8, 9 units. Okay, 9 units is one leg, so 9 equals A. And 1, 2, 3, 4, 5 units. 5 equals B. And so this other side over here, right, we've got this right angle. So this side is C. So 5 squared plus 9 squared equals C squared. So 25 plus 81 equals C squared. So 106 equals C squared. And if we take the square root of both sides, 106 is 10.29, or 10.3 is approximately the value of C. Okay, that's number 42. I'm going to do a couple more here. Let's see if this wants to continue cooperating or not. I'm going to use the Pythagorean theorem because right now I feel like that's, with these points on the coordinate plane, I feel like that's easier. One leg is 2, the other leg is 1, 2, 3, 4, 5. And so 2 squared plus 5 squared equals C, right? Equals C squared. Because the Pythagorean theorem again, a squared plus b squared equals c squared, and that is true in any right triangle, and we just made this a right triangle. So 4 plus 25 equals c squared, 29 equals c squared, and if I take the square root of both sides, the square root of 29 is 5.385, or 5.4, because we were instructed to round to the nearest tenth, and that would be our answer there. I'm going to move on. You can pause anytime you want. Again, we're trying to find the length of the line between the 2 points. 1, 2, 3 units. 1, 2, 3 units. So 3 equals B, 3 equals A. C is the long side, or the hypotenuse. So 3 squared plus 3 squared equals C squared. And that's 9 plus 9 equals C squared. 18 equals C squared. If you want to know what C is equal to, you have to take the square root. And the square root of 18 is 4.24, or 4.2 approximately. Okay, check your answers, keep going, finish up 45 through 49. Thanks for hanging with me.